Welcome to the Security Policies module. This module describes the purpose of security policies. The module also explains the functionality of zone and global policies. Finally, this module explains the functionality of application firewall with unified security policies. At the end of this module, you will be able to describe the purpose of security policies, explain the functionality of zone policies, explain the functionality of global policies, explain the functionality of application firewall with unified security policies. The example reviews packet flow through the SRX series platform. When the device examines the first packet of a flow, the ingress and egress zones are determined based on the routing lookup. Based on zone determination, the device examines the set of security policies corresponding to the traffic. The system checks the packet against the security policies in the policy set to determine how to treat the packet. The focus is on the security policies portion of the security flow module. The Junos OS provides a set of tools to implement network security within your organization. This module examines security policies. Security policies enforce a set of rules for transit traffic, identifying which traffic can pass through the firewall and the actions taken on the traffic as it passes through the firewall. Security policies enable you to decide which users and data can enter and exit the network, as well as where, when, and how. Each rule in a security policy specifies the source IP address, the destination IP address, and application as matching conditions. If a packet arrives that matches all three criteria, the Junos security device performs the action configured in the policy. Policies can allow or deny traffic, but they can also be used to authenticate, prioritize, schedule, filter, and monitor transit traffic. The Junos OS evaluates traffic against security policies in a specific order. Once a rule that matches traffic has been found, the specified action is taken and the policy evaluation ends. Note that unified policies can change security policy ordering evaluation. The example shown describes a scenario where unified policies are not in use. Click each policy to learn more. Because policies execute in the order of their appearance in JWeb, you should be aware of a few points. Zone security policies are checked before global policies, which are checked before the default policy. At each level, policies are checked from the top of the configuration to the bottom until a match is found. Policies with more specific match criteria should generally be higher in the list of policies. Policies with more generic matching criteria, like using any, should generally be lower in the list. New policies go to the end of the policy list. You can change the order of policies in the configuration by using the Move Rule command in JWeb. To secure a network administrator must create a security policy that outlines all of the network resources within that business and the required security level for those resources. Junos OS enables you to configure security policies in JWeb or the CLI. Security policies enforce rules for transit traffic in terms of what traffic can pass through the firewall and the actions that need to take place on traffic as it passes through the firewall. There are two types of security policies: zone and global security policies. Zone security policies allow traffic coming from one zone and going to another zone, a source zone and a destination zone. Note that the source and destination zones of a zone security policy can be the same or it can be different. If the source and destination zones are the same, the policy is considered an intra-zone policy. If both zones are different, the policy is considered an inter-zone policy. This zone-to-zone parameter is called a zone context. Zone security policies are organized by zone contexts as shown in the example. This example shows a packet flow through an SRX series device. The device's interfaces are assigned to 3 security zones: private, external, and public. The business requirement calls for an SSH application to be allowed from host B, located in the private zone, to host D, located in the external zone. To meet the requirement, the security policy is created as illustrated in the example. In the example, host B first initiates the SSH session to host D. The Juno security device then receives the traffic and performs a security policy lookup, looking for policies that match traffic going from the private zone to the external zone. In this example, a security policy exists that permits the traffic. The host B to host D flow triggers the creation of the reverse flow from host D to host B. The example identifies the contents of this newly formed session. The session now consists of 2 flows: source to destination and destination to source. Host D sends the return traffic from host D to host B. The device, using the session created in the previous step, permits the return traffic through host B. Zone security policies reference a source security zone and a destination security zone. This combination of a from zone and to zone is called a context. Each context contains an ordered list of policies. If you want to perform actions on traffic traversing many zone contexts, you have to configure zone security policies for each possible context. To avoid creating multiple security policies for every possible context, you can simplify this task by creating global security policies. Global security policies provide you with the flexibility to configure policies without the need for a specific zone context. The from zone and to zone contexts are not required for a global security policy, but it is possible to add these as match criteria if needed. Global security policies must still reference source addresses, destination addresses, and applications as match conditions, just like a zone security policy. Global security policies are configured in the Configure Security Services Security Policy Rules workspace in JWeb. Addresses for global policies must be defined in the Global Address Book in Configure Security Services Security Policy Objects Global Addresses workspace in JWeb. You can use both zone security policies and global security policies at the same time within a configuration. However, zone security policies are checked first before global policies. For example, if traffic would match both a global security policy and a zone security policy, the action in the zone security policy is applied. Note that unified policies can change the security policy ordering evaluation. The example describes a scenario where unified policies are not in use. The example depicts a scenario in which a global security policy can save you time and system resources. Using zone security policies, you would have to configure 3 security policies to facilitate communication between the HR, engineering, and IT zones out to the external zone. You would also need 2 more security policies per zone to facilitate each host communicating with any other resource in any other zone. A global security policy can accomplish this same requirement in a single policy that would take up to 9 zone-based security policies using zone contexts. Every security policy created generates a security context, which uses system resources. The more security policies there are, the longer it can take the policy engine to evaluate when looking for a match. Therefore, configuring only zone security policies might not scale well, especially in large deployments where there can be thousands of security zones. By default, the Juno's OS denies all traffic through a Juno security device by using a default security policy that denies all packets. You can permit traffic through the device by configuring a zone or a global security policy that permits certain types of traffic, or by configuring the default policy to permit all traffic. You can set the default policy behavior in the Configure, Security Services, Security Policy, Rules, Global Options workspace in JWeb. Some Juno security devices, such as the SRX300 series, ship with a factory default template configuration file that contains the default policy along with 3 pre-configured security policies. Trust to Trust Zone policy permits all intra-zone traffic within the trust zone. Trust to Untrust Zone policy permits all traffic from the trust zone to the untrust zone, and Untrust to Trust Zone policy denies all traffic from the untrust zone to the trust zone. When defining a security policy, you must associate it with a zone-specific or global context. For zone-based security policies, the source zone is referenced as the from zone, and the destination zone is referenced as the to zone, which creates a single zone context. Global security policies do not have a zone context by default. However, you can reference a zone context if needed. Within each context, you can define more than one policy, which are together referred to as an ordered set of policies. The Juno's OS attempts to match traffic to policies in the order of their configuration, starting with zone-based security policies, then global security policies, then the default policy. Each security policy is labeled with a user-defined name. Under the user-defined name is a list of matching criteria and actions, similar to a Juno's routing policy. However, one major difference from a routing policy is that each security policy must contain a matching source address, a destination address, and the application. Actions for matching traffic include permit, deny, or reject. Optionally, configure log or count for policy monitoring. The Juno's OS also uses security policies to invoke the use of several other security features, such as Intrusion Detection and Prevention, or IDP, Unified Threat Management, or UTM, and Firewall Authentication. Each defined policy must include match criteria. Click each criterion to learn more. Each policy has a list of basic and advanced actions available. The basic actions are permit that enables traffic flow, deny that silently drops packets, and reject that drops packets and sends either an internal control message protocol or ICMP unreachable message for UDP traffic or a TCP reset RST message for TCP traffic. For each of these actions, you can configure the Juno's OS to log or count traffic. The best practice is to send logs to an external syslog server. To view counters, navigate to the Monitor, Security Service, Policy, Activities workspace in JWeb. In the example, you can notice 2 major sections. One section for the match criteria and another section for the action parameters of the security policy. Note that security policies are configured within the Configure, Security Services, Security Policy, Rules workspace in JWeb. The rules are organized in the zone context for zone security policies, and global policies are placed in their own section. Zone security policy configuration requires a security policy name, a source zone, a destination zone, the source address, the destination address, and the application. Global security policy configuration requires all the same parameters, except that it does not require a zone context. The use of to-zone or from-zone parameters in a global policy are optional and cannot be added to a global security policy through JWeb. If you wish to add the to-zone or from-zone parameters to a global security policy, you must do so in the CLI. The addresses in both zone and global security policies reference a configured address book entry. With zone security policies, the source addresses need to be defined in the address book attached to the zone referenced in the from zone context, and the destination addresses need to be defined in the address book attached to the zone referenced in the to zone context if you are using zone address books. There is an address book called Global that is associated with all zones, which enables these addresses to be used by any security policy. Global policies which do not have a zone context can only use addresses from the global book. In addition to the basic policy actions, some of the advanced permit settings are also available. A security policy can associate with another type of policy, such as an IDP policy. IDP policies inspect traffic and enforce various attack detection and prevention techniques. A security policy can also associate traffic with other advanced features such as UTM, Secure Sockets Layer or SSL proxy, and Sky Advanced Threat Protection or ATP. Security policies are made up of rules in the Configure, Security Services, Security Policy, Rules workspace in JWeb. In this workspace, you can click the More button to manipulate the security policies. You can perform actions such as moving the rule before or after another rule, cloning the rule, disabling the rule, deleting the rule, as well as other actions shown in the example. Remember that the rule order is important because rules execute in the order of their appearance in the workspace. Unified policies are the security policies that enable you to use dynamic applications as match conditions as part of the existing 5-tuple or 6-tuple, 5-tuple with user firewall match conditions to detect application changes over time. If the traffic matches the security policy rule, one or more actions defined in the policy are applied to the traffic. By adding dynamic applications to the match criteria, the data traffic is classified based on the Layer 7 application inspection results. App ID identifies dynamic or real-time Layer 4 through Layer 7 applications. After a particular application is identified and the matching policy is found, then the actions are applied according to the policy. Unified security policies provide a few benefits. It simplifies application-based security policy management at Layer 7. Enables your device to adapt to the dynamic traffic changes in the network. Provides greater control and extensibility to manage dynamic applications traffic than a traditional security policy. The Unified Policies feature is enhanced to include URL categories as match criteria for web filtering category using an Enhanced Web Filtering or EWF server. URL categories can be configured to Unified Policies with or without dynamic application. When the URL category is configured as URL category any to a security policy, the security policy matches all categories of traffic configured to the unified policies. When the URL category is configured as URL category none to a policy, the URL category is not used in the policy lookup. The unified policy configured with URL category none is considered as the highest priority to policy match for a traffic. When the URL category to a policy is not configured, or when you upgrade to a device from the previous release to the latest release, the URL category of all the policies are considered as URL category none. Note that only the ports that are generally used, such as HTTP and HTTPS traffic, are supported by the URL category feature. Hence, the policy lookup supports HTTP and HTTPS traffic. Stateful firewalling has been the staple of security in most networks for years. This method worked well when it came to keeping track of sessions, network address translation or NAT mappings, protecting against session-based attacks, protecting against connection-oriented protocol attacks, and many other features. However, the problem with stateful firewalls is that the inspection of traffic essentially stops at Layer 4. Only inspecting up to Layer 4 means that the firewall does not inspect the payload of the traffic. This leaves stateful firewalls in a position in which they filter traffic based on Layer 3 and Layer 4 really well, but they are left open to enable application layer exploits. This situation leads us to the technology known as application firewalling. Application firewalling leverages the results of application identification to identify specific applications, no matter which Layer 4 port they use. This helps stop exploits that might use well-known Layer 4 ports, such as TCP port 80, but are not the typical application that runs over the well-known port. Another place that application firewalling is beneficial is in filtering traffic that might not be malicious, but is simply unwanted. For example, as an administrator, you might need to block certain application traffic that is being tunneled through HTTP. To accomplish this task with a stateful firewall, you would have to craft a security policy that blocks a combination of Layer 3 IP addresses and Layer 4 ports. This approach is not feasible from a scaling perspective because the security policy would continue to grow and change as websites changed their IP addressing, and as new unwanted sites are added to the security policy. The AppFW module comes to the rescue by enabling you to block these nested applications based on their application signatures, while still enabling other HTTP traffic to pass through the firewall. Remember that each app secure module, such as AppFW, uses the results from the application system cache, or ASC, to determine which application is present in the traffic flow. To understand the inner workings of the application firewalling function, you must examine how the AppID engine works with the AppFW module. Also, it is important to note that the other security components of the SRX device come into play as well. If the firewall security policy does not allow the packet through the stateful firewall, there is no possible way that the AppFW module will have a chance to examine the packet. When traffic for a new session is processed by the first path algorithm and it passes through a security policy that references an application firewall rule set, the AppID module typically is unable to identify the application. The application identification typically cannot occur within the first few packets of the session because those packets generally do not contain any payload information. Then the server responds by setting up a session between itself and the client host. If no matching entry in the ASC exists, the SRX device must wait for further traffic to enable the AppID module to properly identify the application. Once traffic with application data begins to flow, and the fast path processing on the SRX device has begun, the AppID module can correctly identify the application. Only at this point can the AppFW module act upon the traffic and deny or accept the session. With the introduction of unified security policies, policy evaluation has changed. Before Junos OS version 18.2, if traffic matched a zone security policy and a global security policy, then the Junos OS applies the zone security policy. In Junos OS version 18.2 and later, the security policy evaluation is not as straightforward. The Junos OS still applies zone security policies first, but with some exceptions. The Junos OS applies zone security policies first if there is no dynamic application set or if the dynamic application is set to none for the match criteria. Zone security policies with the dynamic application configured are applied next. The Junos OS then processes global security policies with the dynamic application configured next, and it finally processes global security policies last that have the dynamic application configured. Understanding how the Junos OS evaluates unified security policies might seem a bit difficult. The table gives an example of 12 security policies, 6 zone and 6 global security policies. It also provides information on the state of the dynamic policy configuration. With this information, you can determine the order that the Junos OS evaluates the security policies. The Junos OS evaluates the security policies in the order specified in the table. Unified security policies rely on App ID to perform an application match before the security policy can be matched. This process might not occur immediately because the first few packets of a session typically do not contain application data, or it might take a few moments for App ID to determine the application. In this scenario, the traffic might match more than one unified security policy because App ID has not determined what the application for the session is. In this scenario, the pre-ID default policy options are applied to the session. The session timeout and the session log are applied according to the pre-ID default policy configuration. If the pre-ID default policy is not configured, the session timeout and the session log are applied as per default values in the unified security policy. You can configure the pre-ID default policy to log the session, and you can change the session timeout values as well. You can configure the pre-ID default policy in JWeb by navigating to the Configure, Security Services, Security Policy, Rules Workspace, and clicking the Global Options button. After the Global Options window pops up, you must click the Pre-ID Default Policy tab, and then you can adjust the session timeout values and the logging options for the Pre-ID default policy. The example shows the criteria for the case study. In this scenario, you are managing an SRX series device for a mid-size enterprise. The employees of this business should be able to access Reddit on the Internet, but management has found that far too often users are spending too much time posting comments on Reddit. You must enable Internet access for the users, but you must block any users from posting comments on Reddit. To begin, you must navigate to the Configure, Security Services, Security Policy, Rules Workspace in JWeb. This workspace allows you to create the security policies that you need for this case study. You need to create 2 rules to satisfy the requirements of this case study. The first rule that is created is the rule that allows the users to reach the Internet. To begin, you must name the rule something that is specific, and then select the trust zone as the source zone. The addresses field defaults to the any parameter, which means any source address is allowed through the security policy as long as it is coming into the trust zone. The identity field is left blank by default as it is used for user firewall identification services. Note that in this example, a zone security policy is used, but you could use a global security policy and that would not break the requirements of the case study. To make this policy a global security policy, you would need to select the Global Policy checkbox that is located in the General Information section. Next, you must specify the block parameters by specifying the destination zone. All the other parameters can be left at their defaults. Note that the dynamic application field is set to any by default. This default setting means that any security policies that you create through the JWeb will be a unified policy and is subject to the policy evaluation that was discussed earlier. The addresses and services fields default to a value of any, which means that with this policy, traffic going to any destination using any destination port is permitted as long as it is egressing the untrust zone. Finally, the URL category field is set to none, which means the security policy is not matching on any URL categories. The Advanced Security section allows you to set the rule action, such as permit, deny, reject, and any additional actions, such as Intrusion Prevention System or IPS, UTM, and SSL proxy actions, as well as other options. For the Internet Access Rule, you only need to set the rule action to permit to allow the traffic from the users to the Internet. At the end of the rule creation, JWeb presents you with the Rule Options section. This section allows you to enable session logging and counting, additional authentication options, other advanced settings, and scheduling options. For the case study, you do not need to do anything in this section beside clicking the Finish button to complete the configuration of the rule. Next, you must create the rule that blocks the user's ability to post comments on Reddit. Configuring this rule is very similar to what was shown in configuring the previous rule, so it is not required to go into details about all the options at this point. To meet the criteria of this case study, you must first name the rule and select the trust zone for the source zone as shown in the example. You must now configure the destination parameters for this rule. The destination zone should be set to the untrust zone, and the destination address information should be left at the default of any. Then, you must select the Juno's Reddit Post Dynamic application, as the security policy uses this dynamic application to detect if users are attempting to post comments in Reddit. After selecting the dynamic application, the services field automatically changes to the Juno's defaults value. This value enables the security policy to select the ports that will be in use with the dynamic application automatically. Lastly, you can leave the URL category field at the default value of none. Now you must configure the Advanced Security section. In this section, you must set the rule action to a value of reject. Setting this field to a value of reject allows you to select an SSL proxy profile. The SSL proxy profile is necessary because Reddit, as well as most of the Internet, uses encryption for web traffic. If you have used the deny parameter for the rule action, then you cannot apply an SSL proxy profile to the rule. Note that the creation of SSL proxy profiles is outside of the scope of this course. To finish the rule, you must select the log@session_init time parameter to ensure that any attempts to post a comment on Reddit are logged. Note that if you select the log@session_close time parameter, then no logs are generated as the sessions are never created, and because of this they are never closed as they are rejected from the start. After creating the rules, you might realize that there is going to be a problem. Looking at the rule ordering after creating both rules, you might notice that the Internet Access Rule is shadowing the Block Reddit Posting Rule as it is matching on all traffic that is coming from the trust zone that is going to the untrust zone. In this situation, posting comments on Reddit will be permitted through the SRX as all traffic only matches the Internet Access Rule and bypasses the Block Reddit Posting Rule. To fix this problem, you simply need to move the Block Reddit Posting Rule before the Internet Access Rule. To complete this task, you must select the Block Reddit Posting Rule, click the More button, select the Move Rule option, and then select the Up option as in the example. This action moves the Block Reddit Posting Rule before the Internet Access Rule. Now users can access anything on the Internet, but they are unable to post comments on Reddit. Note that alternatively, you can move the Internet Access Rule after the Block Reddit Posting Rule to ensure that the rules are in the correct order. Finally, although not shown in the example, do not forget to commit the configuration to apply the changes to the SRX device. Welcome to the lab section of this module. In this lab, you configure security policies to control how traffic traverses the VSRX1 device. Then, you send traffic through the VSRX1 device and monitor the effect the security policies have on the traffic. At the end of this lab, you will be able to configure security policies to permit traffic, configure security policies to silently block traffic, verify the effects of the security policies on the traffic that passes through VSRX1. Click the Start button to view a guided demonstration of the lab tasks. Part 1. Loading the baseline configuration. In this lab part, you become familiar with the access details used to access the lab equipment. After this, you use JWeb of the VSRX devices to load the starting configuration for Lab 3. Click each step number to view the step. Consult the management network diagram to determine the management addresses of the devices. Access the JWeb interface of VSRX1 using a web browser. Refer to Administration, Devices, Config Management, Upload Workspace in JWeb. Click Browse and select the lab3 start.config file located in the VSRX1 directory. Click Upload and Commit to apply the configuration to VSRX1. Access the JWeb interface of VSRX VR using a web browser. Refer to the management network diagram for the IP address associated with VSRX VR. From the Open Web Browser to VSRX VR, log in to the VSRX VR device with Lab as the username and Lab123 as the password. Note that both the name and the password are case-sensitive. Navigate to the Administration, Devices, Config Management, Upload Workspace in JWeb. Click Browse and select the lab3 start.config file located in the VSRX VR directory. 9. Click Upload and Commit to apply the configuration to VSRX VR. Part 2. Configuring security policies. In this lab part, you configure zone security policies. Click each step number to view the step. Turn to the Open Web Browser to VSRX1. Navigate to the Configure, Security Services, Security Policy, Objects, Global Addresses workspace in JWeb. Select the Global Address Book and click the Edit button. Click the Add button to begin adding a new address book entry. Create a new address book entry for the prefix in the trust zone with the displayed parameters and click OK. Create a new address book entry for the prefix in the DMZ zone with the displayed parameters and click OK. Examine the current Edit Address Book Global window. Click OK and navigate to the Configure, Security Services, Security Policy, Rules workspace. Click the Add button to begin creating a new security policy rule. Name the rule Trust Internet Access and click Next. Set the source zone to Trust and click the blue Select link next to the Addresses field to choose the address book object. Select Include Specific from the Address Selection list. This will open another window below. Select the TrustNet address object and move it to the selected window. Then click OK to complete picking the source address. click Next to continue. Make sure that the destination zone is set to Untrust and leave all the other parameters at their default values. Click Next to continue. Set the Rule Action field to Permit and click Next to continue. Leave all the parameters in the Rule Options section at their default values and click Finish. Review the summary of the new rule. Click OK when complete. Click the Add button to begin creating a new security policy rule. Name the rule Trust DMZ Access and click Next. Set the source zone to Trust and click the blue Select link next to the Addresses field to select Include Specific from the address selection list. This will open another window below. Select the DMZ net address object and move it to the selected window. Then click OK to complete picking the source address. Verify that the zone is Trust and the address object is DMZ net. Click Next to continue. Make sure that the destination zone is set to DMZ and change the entry in the Addresses field to match the address book object that references the DMZ zone prefix. Change the entry in the Services field to match the FTP and ping traffic. Note that when FTP and ping are selected, they do not have the Junos prefix attached. Leave all the other parameters at their default values. Click Next to continue. From the Rule Action drop-down list, select Permit and click Next to continue. Leave all the parameters in the Rule Options section at their default values and click Finish. Review the summary of the new rule. Click OK when complete. Click the Add button to begin creating a new security policy rule. Name the rule Trust DMZ Block and click Next. Set the source zone to Trust and change the Addresses field to match the address book object that references the Trust Zone prefix. Click Next to continue. Make sure that the destination zone is set to DMZ and change the Addresses field to match the address book object that references the DMZ zone prefix. Ensure that the Rule Action field is set to Deny and click Next to continue. Select the Log at Session Init Time option and leave the rest of the parameters in the Rule Options section at their default values and click Finish. Review the summary of the new rule. Click OK when complete. Click the Add button to begin creating a new security policy rule. Name the rule Untrust DMZ Access and click Next. Set the source zone to Untrust and leave the Addresses field to match any host on the Internet. Click Next to continue. Make sure that the destination zone is set to DMZ and change the Addresses field to match the address book object that references the DMZ zone prefix. Change the Services field to match the SSH traffic. Leave all the other parameters at their default values. Click Next to continue. Ensure that the Rule Action field is set to Permit and click Next to continue. Select the Log at Session Close Time and Log at Session Init Time options and leave the rest of the parameters in the Rule Options section at their default values and click Finish. Review the summary of the new rule. Click OK when complete. Examine the Configure, Security Services, Security Policy, Rules workspace. Click the icon next to the Trust to DMZ context. Select the Trust DMZ Access rule and click the Edit button. Click the Source Address field for the Trust DMZ Access rule. Or add the Trust Net Address object. Remove the DMZ Net Address object and click OK. Click Update to save the changes to the rule. Click Save to update the changes. 47. Commit the changes by clicking Commit Options and selecting the Commit option. Part 3. Verifying Security Policies. In this lab part, you send traffic through VSRX1 and monitor the effects of it. Click each step number to view the step. Access the CLI of VSRX-VR using either the console or SSH. From the CLI of VSRX-VR, log in with lab as the username and lab123 as the password. Note that both the name and the password are case-sensitive. Initiate a ping from the host in the trust host to the Internet host by issuing the ping 172.31.15.1 count 5 routing instance trust command. Initiate a ping from the trust host to the DMZ host by issuing the ping 10.10.102.10 count 5 routing instance DMZ command. Initiate an SSH session from the trust host to the DMZ host by issuing the SSH 10.10.102.10 routing instance trust command. Press the Ctrl+C key combination to stop the SSH session attempt if it has not timed out already. Initiate an SSH session from the Internet host to the DMZ host by issuing the SSH 172.18.1.1 routing instance Internet host command. When prompted, log in with lab as the username and lab123 as the password. Issue the exit command to close the SSH session with the DMZ host. Return to the open web browser to VSRX1. Navigate to the Monitor, Security Services, Policy, Activities workspace in JWeb. Examine the Monitor, Security Services, Policy, Activities workspace. From the Policy Context drop-down menu, select the Trust to DMZ context and click the search icon. Examine the resulting output for the Trust to DMZ zone context. Click the icon in the View Logs field for the Trust DMZ block security policy. Close the Policy Logs window and click the Go To link next to the To Enable Logs field to discover where you should go to enable logging. Click Enable to go to the Monitor, Alarms, Policy Log workspace. Click Create Log and click Yes when asked if you want to proceed. Return to the Open CLI session to VSRX-VR. Initiate an SSH session from the trust host to the DMZ host by issuing the SSH 10.10.102.10 routing instance trust command. Return to the open web browser to VSRX1. Close the Policy Logs window and click the icon in the View Logs field. Close the Policy Logs window. Return to the Open CLI session to VSRX-VR. Initiate a fast ping from the host in the trust host to the Internet host by issuing the ping 172.31.15.1 rapid count 1 million routing instance trust command. Return to the open web browser to VSRX1. Change the zone context to Trust to Untrust. Click Enable in the Policy Hit Counters graph section. Click Enable in the Enabling Count window. Expand the Trust to Untrust zone context. Select the Trust Internet Access rule and click the Edit button.